So what we're interested in today is to think about solving equations where the pieces of the equation involve trig functions. It's not different from solving algebraic equations in that we want to figure out possible values that work. All that's different is that we might want to take into account periodicity of trig functions and angles that work in terms of other related angles that work. Sine theta is root 3 over 2. What angles could make that happen? One possibility is to keep track in terms of the period of the sine function, and 2 pi as the period means that we could draw in angles where sine theta is root 3 over 2. Maybe a natural thing to since 2's on the bottom, and 2 would be the radius of like opposite over hypotenuse. 2 could be the hypotenuse. So maybe the natural thing would be to draw this into a triangle whose radius is 2. And a triangle whose radius is 2 would have sine root 3 over 2 happening where we've got an angle of pi over 3 in quadrant 1. Well, what's relevant is that it is for the sine function opposite over hypotenuse, and opposite would be positive as well in quadrant 2 as in quadrant 1. So we've got another picture that we could draw in and make it so that we're keeping track of an angle with a reference angle of pi over 3 that makes the angle 2 pi over 3. So that we're keeping track of angles where the ratio is root 3 over 2 for angles where the reference angle is in quadrant 1 or the reference angle is in quadrant 2. So we could make that happen by keeping track of pi over 3 as an angle in quadrant 1 or 2 pi over 3 as an angle in quadrant 2, and make the general solution to that trig equation the quadrant 1 angle translated by multiples of 2 pi so that we get an angle that's coterminal with where we started, or 2 pi over 3, again translated by multiples of 2 pi. Here's an equation to solve. Sine 4 theta is root 3 over 2. Well, we've kind of been here earlier. We talked about sine theta is root 3 over 2. Let's break this apart in two pieces. One piece is to keep track of what the angle is that's the argument of the trig function. So sine of 4 theta, let's keep track of what 4 theta is by that restriction. And after we know what 4 theta is, we'll recover what theta is algebraically by solving for theta in appropriate values for sine of 4 theta. So, sine 4 theta is root 3 over 2. That means that we could take 4 theta as an angle whose sine is root 3 over 2. Well, root 3 over 2 for the sine goes with a 60-degree angle. That's pi over 3. So pi over 3 and multiples of pi over 3 times 2 pi added to a multiple of 2 pi added to that would be an angle that's coterminal with pi over 3. So that's where we should look. So 4 theta is 2 pi over 3 plus 2 pi times k. Either an angle in quadrant 1 is the reference angle, or an angle in quadrant 2. And that means that we can keep track of what theta is by dividing this one through by 4, or dividing this one through by 4. 2 pi over 3 divided by 4 is pi over 6. Pi over 3 divided by 4 is pi over 12. 2 pi over k divided by 4 is pi over 2. So instead of being a multiple of 2 pi, it's a multiple of pi over 2 in either case. And those are the angles that would work for that. So we're keeping track of possible values of the sine function to keep for an angle in quadrant 1 or an angle in quadrant 2, and then translated. Let's do it for a numerical case. Sine theta equals 0.2. Well, theta as sine inverse of 0.2 comes out to be a particular numerical value. Let me pull up the calculator and show you that. You've been here before, so the calculator, what we're interested in is 0.2 as a value for an angle whose sine is 0.2. So 0.2, and we'll do it in radians. Keep track of inverse sine. This number 0.201,357, I show it here as 0.2014. Now the point is that when you've got a value that works, this is an angle that works in quadrant 1, but there is another angle that would be appropriate to use in quadrant 4, or rather in quadrant 2. Pi minus that angle is an angle in quadrant 2, which also has sine equal to 0.2. So this 2.9402 is another possible choice. Let me show you from the calculator. Suppose we do, in terms of radians, suppose we do 2.9402 and calculate the sine. The value that comes out is 0.2 and some mess that's down there for the round off, so 0.2. The other value that we said would work was 0.2014, so if we plug in 0.2014 and see what the sine of that is, again 0.2 and then some crap down here that is sort of the round off part. In either case, we've got an angle whose sine is 0.2. We've got an angle that satisfies that equation, and we've solved the trig equation that way.